Pluto's hidden ocean. What is it really hiding? For most of modern astronomy, Pluto was viewed as little more than a frozen, distant rock at the far edge of our solar system. A cold, silent body drifting in the darkness, largely forgotten since it was demoted from planet to dwarf planet in 2006. At nearly 6 billion kilometers from Earth, Pluto appeared too small, too distant, and too cold to hold any significant secrets. But in recent years, that perception has changed in the most dramatic way imaginable. Thanks to the powerful eyes of the James Webb Space Telescope, Pluto is no longer a symbol of isolation and insignificance. Instead, it has become a beacon of cosmic mystery, holding secrets that could rewrite our understanding of life, planetary science, and the very structure of our solar system. These new images don't just reveal more detail, they suggest that Pluto is far more active, dynamic, and possibly even alive, in a way no one expected. The once dead world we thought we understood now appears to be hiding something astonishing beneath its icy surface. A vast subsurface ocean, strange heat signatures, and a unique geological history. Suddenly, Pluto is no longer a frozen relic. It might just be one of the most interesting places in the solar system. At the heart of Pluto's icy surface lies its most striking feature, a massive, heart-shaped region called Sputnik Planitia. This glacial plain, made primarily of nitrogen ice, stretches for over 1,000 kilometers and is so massive it actually affects how Pluto spins. Yet beneath this serene, frozen landscape may lurk something far more fascinating, a hidden liquid ocean, shielded by kilometers of ice and kept warm by internal heat sources. This subsurface ocean, if confirmed, would be one of the most profound discoveries in planetary science. Pluto, located in one of the coldest regions of the solar system, should be frozen solid. So how could water possibly remain in a liquid state? The answer may lie in Pluto's rocky core, which generates heat through radioactive decay. As radioactive elements break down over billions of years, they produce enough heat to warm the surrounding layers. This warmth may be just enough to prevent the ocean from freezing entirely. The implications are staggering. On Earth, wherever there's liquid water, there's life. Could the same be true for Pluto? Some scientists believe so. And the signs are starting to add up. Pluto's surface is etched with tectonic fractures, faults, and rift-like valleys, features that point to recent or ongoing geological activity. These movements suggest Pluto isn't geologically dead. Instead, it may still be flexing, shifting, and changing, even without the sun's warmth. That alone is surprising. But what's even more startling are the heat anomalies and chemical signals picked up by instruments on the James Webb Telescope. These strange heat signatures, localized, persistent areas of thermal energy, don't seem to match what we'd expect from sunlight alone. Some of them resemble patterns associated with biological processes here on Earth. And that raises an unsettling question. What if Pluto isn't just habitable, it's already inhabited? Of course, any life beneath Pluto's ice would look nothing like what we see on the surface of our planet. With no sunlight, these organisms would have to rely on chemosynthesis, a process where microbes derive energy from chemical reactions rather than light. Similar life forms exist deep under Earth's oceans near hydrothermal vents. Could such extreme organisms exist on Pluto, evolving slowly over billions of years in an environment of cold, darkness, and pressure? Physicist Brian Cox has remarked that even discovering a single microbial species on Pluto would revolutionize our understanding of biology and the conditions required for life. It would prove that life isn't rare, it's adaptable, diverse, and potentially everywhere. But there's also a darker possibility. What if the life hiding under Pluto's ice is more advanced? More complex? Even more ancient than we can imagine? Theories abound. Some researchers speculate that Pluto's subsurface ocean could be home to entire ecosystems, preserved and hidden for eons. These life forms could be adapted to conditions that would kill anything from Earth. And if life formed there once, it might still be thriving, completely isolated from the rest of the solar system. To understand Pluto's strange behavior, we must also look at its closest companion, Charon, its largest moon. Pluto and Charon form a unique binary system where both bodies orbit a common center of gravity. This close gravitational relationship produces tidal forces that influence each other's geology and motion. Charon itself displays signs of tectonic activity, deep surface fractures, icy chasms, and a mysterious reddish polar cap likely caused by frozen gases from Pluto's atmosphere. These interactions suggest that energy is being transferred between the two bodies, possibly helping to maintain Pluto's internal heat and dynamic surface. Pluto also has a thin but layered atmosphere, composed mainly of nitrogen with traces of methane and carbon monoxide. While it may seem fragile, this atmosphere creates stunning visual effects, such as soft hazes, colorful skies, and even snowfall. Organic compounds known as tholins form when solar radiation interacts with atmospheric gases, giving Pluto its reddish-brown color. These tholins may be the building blocks of more complex chemistry, and possibly the precursors to life. Could this complex chemistry, combined with internal warmth and a liquid ocean, mean that Pluto is more Earth-like than we ever imagined? Even more intriguingly, some scientists have raised the possibility that Pluto may possess a magnetic field, though no direct measurements have confirmed it yet. If such a field exists, it could protect Pluto's ocean from radiation and help preserve its atmosphere, similar to how Earth's magnetic field shelters life. This might explain why Pluto shows signs of activity while other icy bodies do not. The idea that such a small, distant world could harbor life, or even complex chemical systems, is nothing short of astonishing. But it doesn't stop there. Pluto's location in the Kuiper Belt, a vast region of icy bodies beyond Neptune, puts it at the crossroads of cosmic forces. Gravitational tugs from neighboring objects, solar radiation, and ancient impacts have all shaped its evolution. Some researchers believe Pluto was born from catastrophic collisions early in the solar system's history. These violent impacts would have melted internal ice and created heat, possibly setting the stage for long-term geological activity. Over time, radioactive decay continued to provide heat, keeping the ocean alive beneath its icy armor. It's a world forged in fire and frozen in time, yet somehow still active. This possibility leads us to wonder, how many other Pluto-like objects are out there? If Pluto is dynamic, what about Eris, Haumea, Makemake, or other dwarf planets and large Kuiper Belt objects? Could they also host subsurface oceans, organic molecules, or even primitive ecosystems? If so, our solar system may be teeming with icy worlds that are not dead, but dormant, waiting for discovery. The New Horizons mission in 2015 gave us our first close-up view of Pluto, but it was just a brief flyby. To truly understand what's happening beneath Pluto's crust, we need new missions, ones equipped with orbiters, landers, drills, and subsurface probes. We need to sample its atmosphere, analyze its internal chemistry, and explore the ocean hidden deep below. Technological advances over the next decade may finally allow us to penetrate Pluto's icy veil and answer the questions we've only just begun to ask. Is there life beneath the ice? Is Pluto unique, or just the first of many such worlds waiting in the shadows? One thing is now clear. Pluto is not a frozen relic at the edge of nothingness. It is a living laboratory, a geologically complex, potentially habitable world that challenges everything we thought we knew about the outer solar system. So, what do you think is hiding beneath Pluto's icy heart? Could it be simple microbial life, slowly feeding off chemical energy? Could it be something more ancient, more complex, more alien than we dare imagine? Pluto asks us not just to explore, it dares us to rethink. To wonder. To dream. In this quiet, cold corner of the universe, a new chapter in planetary science is beginning. A world once written off is now calling us back, demanding a closer look, promising secrets that could change everything. Subscribe to Discovery at 2.0 and join us on this journey. Because the more we learn about Pluto, the more we realize, the story has only just begun.